All right. Sorry, always a mission. Cool. Welcome back. So today we're going to be doing visualizations for the first time, so pretty exciting. Um, kind of cool sidebar. Just wanted to share a little story. I live in the South Bay, so I was driving up to Berkeley right now, listening to NPR, and they're doing a really cool story about the effect of basically like unconditional cash given to low-income families. And it was pretty interesting. Like the entire time they were talking about how they were trying to assess causality. And there've been studies in the past that have shown that if you have like more money in your family, then the development of the child is just so much better. Like you have better like brain activity and all these things. But a lot of people argue that, well, you don't really know if it's like the money, it could be something else. So they actually did a randomized control experiment. So they took a bunch of low-income families, they randomly assigned some of them to get unconditional cash infusion of like $300 a month or something like that. And then the other families didn't get anything. And then they compared the brain activity of children in their first year after being born. And the brain activity was actually much higher in the families that got the cash infusion. So it was very interesting because they basically controlled for like everything by doing a randomized control experiment. So I'll probably post that story on Ed, but it was very, very fascinating. And they use data science in kind of the right way to show the effect of essentially a higher income and how that helps the development of a child. So definitely check that out. I'll post it on Ed later. Cool. So some announcements. So as you mentioned on Monday, Lab 1 regrades due tonight. And then homework 2 is due this week as well, as usual. Lab 3 is due on Friday. And then we have that post out now to sort out the exam conflicts. So if you foresee having any sort of time conflict with your midterm or final, please check out post 389 on Ed. And please respond to that in a timely manner so we can get you all set up. Any questions before we kind of get to the actual meat of the lecture? Cool. Oh, actually, this is a good question on the chat. Was this study double blind that I was talking about? That's a good point. I don't know if it was double blind. I think like the way they did it was they gave them like these debit cards, which had like money preloaded on it. So I imagine they knew that they were giving them debit cards. So I don't think they gave it to like both people, like a placebo, like a debit card without any money, because you'd notice pretty quickly that doesn't have money. So yeah, it probably wasn't double blind. They may not have even been blind, but I mean, they maybe didn't even know that they were like, some people were getting it, some people weren't. So yeah, that's interesting. I'd be curious to see like how they actually set up the study. Good question though. Cool. So yeah, basically with weekly goals, just kind of continuing down this path. So we got to do a little bit of stuff with the census data. We didn't quite get to do too much. We explained it quite a bit, but today we'll actually try to do some visualization using the census data and then some other data sets as well. And then hopefully if we have time at the end, we'll talk about distributions. Don't worry if you don't know what that is. We'll cover that today. Cool. So one thing to kind of just mention to set up some of the context for what we're going to be doing today is this idea of attribute types. So in general, in data science, we're going to have a data set and there's going to be these attributes that we're studying. So when I say attribute, you should just think of like column. That's the same thing as a column in a table. So every column is an attribute. And then a lot of times we'll use the word variable. That's the same thing. So variable, attribute, think of that as just like a column in a table. That's all it really is. And so that's usually something that you're interested in studying. So for example, in the census data, we had like an attribute for like sex, we had an attribute for age, how old you are. So those are different things, different properties about our individuals that we might want to study, right? So that's basically all it is. And there's going to be mainly two kinds of attributes that we're going to study for the most part in this class. And the idea is that all the values, we talked about this last time, but basically all the values in the column of a table need to have that same sort of type. So like if it's a number, they need to all be numbers in the column. If it's a string, they need to all be strings in the column. And that delineation that you're seeing there between sort of like numbers and like almost like text is actually a pretty nice way to separate the two types of attributes that we're going to be talking about. And so the first kind is called numerical. So this would be like an integer or a float. And so each value is on a numerical scale, and the numerical measurements are ordered as well. So like if I have an age of 5, that's more than an age of 3. Like there's an ordering there. I can say that this is more than this, right? So that's typically what we mean when we say numerical. And then the differences are also meaningful. So like 5 is 2 more than 3, but like 10, if you're 10 years old, you're a lot older than a 2-year-old than if you're a 5-year-old. So the difference is meaningful, and then the scale of that difference also, matters. So for numerical data in general, you should have these things being true. And then on the other hand, a categorical attribute or variable is such that each value is from like a fixed set of values. So like, for example, a good category could be like, let's say we were doing a survey of like students at Berkeley, maybe we're asking them like how old they are. We're also asking them maybe like what major they're declared. So your major could be something that's categorical. There's no way to really like order the majors, right? I mean, you could like alphabetically order them, I guess, but like you wouldn't really, it doesn't really mean anything other than just they're alphabetically ordered. And there's no differences like math to geography versus like history. Like there's not really a way to compute like differences really. And so that's how we think about it with categorical. It's just like, think of it like it's a fixed set of possible responses. And there's no clear like ordering or comparisons there. So any questions about the two types of attributes? Okay, so the cool question in the chat here is month categorical numerical. So like the month of the year, like January, February. That's interesting. I would still consider that categorical, but if you were to like represent it as actual numbers, like month 1, month 2, month 3, then you could think of it as numerical. I think that would be okay, because there is like a difference that's meaningful there, right? Like February is much closer to January than like July is. So that's actually okay. So if you represented it as a number, then that'd be fine. You can consider it numerical. Free response, I would probably consider it categorical. Obviously you have like an infinite set of responses you could give in that situation, but they are all like different. And in general, when you see like strings, anything that's like text, that's just basically categorical. Think of it just like that. It's okay if there's like a lot of possible categories. But yeah, there's no way to really like necessarily compare like two different responses there. Cool. And so one note about the numerical attributes is just because the value is a number, it doesn't necessarily mean the attribute is numerical. So it's kind of like, if it's numerical, it should be a number, but if it's a number, it's not necessarily numerical. And so the census has an example of this. So the sex code was represented as numbers 0, 1, 2, but you would still consider this categories. It was just that for like storage efficiency, we wanted to make it a number. But like you wouldn't really be doing like arithmetic or math on this. Like you wouldn't try to find like the average like sex or something like 1 plus, you wouldn't do like 1 plus 2 then divided by how many there are or whatever. Like that type of stuff doesn't really make sense. And so just something to keep in mind. That like technically you can do arithmetic on it, but like your answer isn't going to really mean anything. In this case, like 0 is representing the total. So like what is the like something that's between 0 and 1? Like what does that even mean? It doesn't mean anything. So just keep that in mind there, that could happen. And basically we're just going to think of these as actually categorical. So just remember like where is this data coming from? What is this column or this attribute actually representing? Fundamentally, don't just think about like what am I seeing in the table, but like take a step back and just think about what is this actually representing? Is this actually a category, or is it actually something that's like an ordered numerical thing? Cool. Any other questions? Sweet. So we're going to go over some ways to create visualizations for numerical data, and then we're also going to go over some ways to create visualizations of categorical data. And so with numerical data, there's going to be two main ways that we're going to do this. So one is going to be a line plot, and this is going to be generated using the plot function. And so it looks like this on the left here. And so you're typically going to use this when you have something that is like a sequence or something over time, maybe we're trying to look at some sort of trend. And then a scatter plot is going to be used to show some numerical attribute against another numerical attribute, but we're not necessarily like, there's some sort of like sequential relationship going on. So in this case, you're seeing like number of movies, and then over here you have average per movie. So this is actually like, I think the average gross revenue per movie in millions. And so this isn't something that's necessarily like a sequence of values along the bottom. And so this is where like a scatter plot would be more accurate or more appropriate. If you use like a line plot here, you'd have some really weird lines like going back and forth and like doesn't really make sense. A good other way to think about it is if you're trying to plot like two numerical attributes against each other, like one over here and one up here, you want to make sure that as you're drawing that line from left to right, you're not like staying at one spot or doubling back. So if you ever have like more than one value for any particular value along the bottom, you shouldn't be using a line plot. The line plot should just kind of go all the way there. It should never like come back and go back. That means you probably should be using a scatter plot. And so we'll do some examples of this right now. Cool. So we're just going to read in the same census table that we had from last time. I've done a couple things here really quickly. So, we read in the table using read table, dot read underscore table. And then we've selected only certain columns because last time we mentioned there's like a bunch of additional columns in this CSV file. So we're just selecting sex, age, the population estimate in 2014, the population estimate in 2019. And then all we've done here is just relabeled these really long column names into something shorter, just 2014, 2019. And so now we have our entire table here. And then again, remember, sex is 0, meaning that it's the total. So this first line is everybody who is 0 years old in 2014, and then in 2019. And then everybody who's 1 year old in 2014, 2019, and so on. And so what we're going to do is try to make some plots here. And so one thing we're going to do, first of all, is remove the rows where the age is 999. If you remember, 999 was the code for the total for everybody in the age column. And so what we want to do is we want to do things and show how the population changes maybe as a function of your age. So like, how many people are there for each age group? And how does that look if you're like starting at 0 and going all the way to like 100? So we want to remove the total because the total is going to mess up the plot. We don't want something to be plotted at like 999. That doesn't really make sense. So let's just remove that. And so we're going to call this new table no 999. And then all we have to do is basically simple dot where age, and then we can just do like r dot below 999 because everything else should be well below 999. And then we can just take a look at what that is. Oops. And so it's going to look basically the same as above, but there's much fewer rows here. So not a lot fewer, actually, just 3 fewer. But basically up here we had 296 rows emitted. Now we have 293 rows emitted. And then let's try to make our first chart actually. So what I'm going to do is just take no 999, and then we're just going to look at the rows where the sex is 0. So this is going to be just the totals for each age. Because right now, for every single age, we have 3 entries in this table. We have total, we have male, we have female. So I just want to remove all the male and female and just look at total. And so that's what we're doing here. And then to plot this, now I have just the totals, what I can do is overall.plot. And then we pass in 2 arguments here. So I'm going to pass in age, which is what I want to be on the bottom. And then I'm going to pass in 2019, which is what I want to be on the top. So 2019 is just the population estimate in 2019. And so if you take a look at this, this is what it looks like. So what this is really saying is that in 2019, there were, roughly this many people. I think this is what, like 40,000, I want to say, or 400,000 maybe, people who are 0 years old. And then if you go to 1 year old, it's like slightly more. But then as you see around 60, the population like starts to drop quite a bit. And then you see a little bump up here at 100. Anyone remember why that bump might be happening? Why is it going up at 100? Yeah. Yeah, so 100 has everybody who is 100 and above. It's just all been lumped together into 100. Just to like simplify the table a bit. So that's why you see this like spike at 100. So yeah, otherwise that's not like physically possible really. You wouldn't think. So yeah, so that's kind of why it looks like that. And so this is our first plot. And in general, it's good to also label your plots. So if you're making a plot, it's good to have some sort of like title at the top that's saying, what is this plot about? And so there's a few ways that we can do this. So one way you can do it, which is quite simple in Python, is if you're writing your code like this, you could just leave a comment. So you use the pound symbol here, and then you can just leave a comment. So I could say like US population. And this is like a totally valid way to like label your plot in your Jupyter notebooks, just so you know like what you're looking at. So you can just leave a little comment there above the line of code. Another way we can do it is we can actually print it out. So we can print out the name that we want for the plot. So I'm just going to copy this US population, and then I can just go here and do print US population. And so that what that will do is it's going to make my plot, and then it's going to write out US population right above as well. So that's also a perfectly fine way of doing it. And then if you want to get like really fancy, you can actually get the title into the plot itself. And you do not need to know this for data 8, but I'll show it to you guys anyway. And to do that, you do plots.title. Whoops, that's not what I wanted. The actual title of the plot. So put this in here, and then you do need a semicolon at the end. And then it gets it right there inside the plot itself at the top. So a few different ways to do that. But in general, it's good to label your plots, have a title at the top, just so if you're showing your visualization to somebody, they can understand what's going on. Any questions about that? Yeah. Oh yeah, so why is there the bump at the 100 again? It's because you have, if we actually had like rows for all the ages past 100, like 100, 101, 102, and so on, you'd see this line plot like continuing to go to the right. But the way the table is actually structured is that it stops at 100, and they didn't want to just like keep adding a bunch of rows. So basically they just took like everybody who was 100, 101, 102, and so on, and just put them all together into the 100. Yeah. Yeah. Sorry, I'm not able to hear you too well. Oh yeah, why was the title printed first, even though it was the second line? That's just the way that I guess this is done in Python. Like you kind of construct the plot initially, and then add the title later. For this one, that's also interesting. Yeah, I think what Python typically will do is like, if you're returning something that's not a print statement, it will typically be shown after within a cell, and the print statements will come first. It's just kind of the way Python does it. It is a little bit strange. But yeah, that's just the way Python does it. Yeah.
Would it do the same thing if we flip the lines of code?
That's a good question. Would it do the same thing if we flip the lines of code? Let's actually try that. Let's see. Yeah, it looks like it is the same thing. Nice. Oh, this is also a good question. So how does plots.title know that like this title needs to go inside this chart? Because like we did this in a different line, and then somehow it just knows. And that's basically the explanation, is that it just knows. So Python knows when you do overall.plot, we're kind of simplifying some of the code you're having to do here. It's doing some things under the hood. And so when you do plots.title, it does know actually that like you've created this plot previously so far, and like you want to add this title to it. So a little bit of fancy stuff going on under the hood there. Yeah. Which plot you want to what? Oh, which plot you want the title to go on? That's interesting. So if you're doing multiple plots, I would just keep them in probably like separate cells for now. At least it's a little bit beyond the scope of this class for like adding the titles to like different plots at once. But if you do more Python, you'll definitely learn how to do that a little bit more. But yeah, for now, what I would do is just try to keep them in separate cells, and then you can have like the title on each plot as you're making each plot. Yeah. Yes. Why does it alter the scale of the y-axis, but not the x-axis? Oh, like, because you mean it's not saying like all the numbers here, it's just saying 5. Do you mean by that? Yeah. Yeah, I mean, so it's not necessarily like a Python thing. It's actually just the way that this module was written. It's kind of intelligent in that it knows that like, if you're going to be showing like lots of zeros, your plot's going to look really ugly, right? Like all of these 1, 2, 3, 4 would have like a bunch of zeros after it. So instead of doing that, it just puts this 1e6, like 1 times 10 to the 6th at the top, and then it puts the numbers really cleanly there. Yeah, in terms of changing that, I don't think there's too much customization on this actual plot function. But if you were to use like your own modules down the road, as you do more Python, then you have like a lot more customization ability. But basically the data science module does a little bit of the hand-holding for you there. Cool. All right, good questions. So another thing we can try to do here is, it'd be interesting to look at the same exact plot, but maybe male versus female. Let's just see like if you see anything interesting Maybe they look different, maybe they look the same, but it'd be kind of cool to just compare. So what we're going to do is we're going to assign from no 99 just the rows where sex is male. So we can do sex 1, and then I'm just going to drop the sex column because we don't really need it at that point since everybody is sex 1 in that one. And then we'll do the same thing for females, but sex 2. All right, so this is just taking this kind of original table, which doesn't have the totals of the ages, and then just filtering by sex. And then we're going to put this together into a new table called POP 2019. And I'll explain in a second why we're putting this into a new table. But basically, we're just going to combine all the data into this one table. So our first attribute is going to be age. So this is just going to be males.column age. Our second attribute is going to be males. And so this will be males.column. Let's take the 2019 estimates, and then we'll do the same thing for the females. So females.column 2019. All right, so we put this all into a table, and actually let's just show you what this table looks like. Let's just show the first 5 rows. So here what this table has is now we have age as one column, which we kind of already did that before, but now we have males and females as their own separate numbers on each column. So the original no 99 didn't have it like that. It was almost like you had like 0 all the way up to 100 for males, then 0 up to 100 for females below it. So what we did was we kind of like put it together. So now you can all compare them across one age group. So that's basically what we did there. And then what's nice about this is now if I want to plot both of them against age, it's really easy. So I can just do pop 2019.plot age, and I just don't even have to specify any other columns. I can just put in one argument of age, and it knows that it's going to just plot everything else against age. And so when I do this, we get to see both of them on top of each other. And so it's like a nice, simple way to do it. And so in general, that's how the plot function is going to work. So, if you want to be explicit, pass in 2 arguments, but if you want to plot like multiple things against something, just pass in the 1 argument. And so, yeah, any interesting things that you guys notice here on this plot? Anything that stands out, look basically the same. Yeah. There's a higher population of females, you said, on the right side, on the slightly, right? Yeah. Yeah, definitely, especially like after like, what's this, like maybe 55 or something like that, right? You see like kind of a higher population, pretty much for every age group. It's like always higher pretty much all the way down to the end. Kind of in between here, right, 40 to 55, it's like about the same. Before that, surprisingly, the male's always higher. It's like really weird. I don't know why that is. Surprisingly, this is actually a phenomenon that's true in like most countries. Very bizarre, but happens to be the case. And then after 55, it kind of reverses. So kind of interesting. And so what we can do is we can actually try to quantify this sort of change in how they're going up and down into like one number. And so what we're going to do is we're going to just calculate the percent of the population that is female. Instead of looking at male versus female, we're just going to calculate the percent that's female for every single age group. And so we can do this really quickly in Python. So firstly, what we'll do is we'll just get the total population. So we'll just take the males column and add the females column. Then what we can do is look at the percent female. So we'll do top 2019 column females divided by total times 100. So, this is going to give us kind of the percentage of both these groups combined, male and female, that's female. And then we're going to multiply by 100 because otherwise we're just going to have like a decimal number there. And then we can just take a look at what this looks like here really quickly. Oh no, females. There we go. So now we have the percent. And so this is basically showing you, this is going to be like age 0, age 1, and then at the very end we have age 100. And so you can kind of check that the numbers are sort of aligning with what we saw in the plot. It was kind of below 50%, but then ended up being above 50% towards the end there. And then this is a little bit hard to see, so you can even like round this if you want to, just to make it a little easier, because like you don't necessarily need to see like all the decimal places. It's not necessarily helpful. So we could just do np.round percent female, and we could round this to like 3 decimal places, let's say, and then take a look at that. So this is a little bit easier to read. And then what we can do is we can add this to our table actually. So let's do pop 2019 with column. Let's just call it %female. And then we're going to just pass in that array that we just created. So then we can take a look at our table now, and it has this new column here on the right here. And then what we wanted to do was basically just plot that thing over time. So now that it's in a table, now it's quite easy to plot it using the techniques we've used before. We just use pop2019.plot age, and then here we want to specify specifically which column we want, because you don't want to plot everything, you just wanted to plot this one. And so you can see it looks like this. So do you guys see any issues with this plot? Anything that could be done better? Yeah. Yeah, so he basically said the y-axis doesn't start at 0, it starts at like 45 or something. So this spike looks like super dramatic, when like actually it probably isn't that dramatic. I mean, it is dramatic, it's definitely like crazy high, but it's not like as dramatic as what's been shown here, right? This is a little bit sensationalized. So we can do, and again, you don't need to know this for this class, but I'll just show you, is you can actually change the limits of the y-axis. So if I go in and write this, it's going to be from 0 to 100 rather than like whatever Python was doing by default. And so now it shows you what the actual change looks like. So still pretty dramatic, but not as crazy as what was shown above. And so this is really important to keep in mind when you're making visualizations. Always look at the y-axis, super, super important. If it's not starting at 0, someone's probably trying to spin a story. So just make sure you're looking at the y-axis, super, super important. And I'll show you a pretty funny example of this that was actually shown on the news in the slides later. But yeah, good call on that one. Cool. All right, so those are how we can plot, do line plots. I guess we should also do the scatter plots actually. So let's actually go do some scatter plots. So for this one, we're going to use a slightly different data set. So, whoops, actors. This is going to be a table of a bunch of actors who've like been in some really high grossing movies. So we can zoom in here a little bit. So you can see kind of the name of the actor, the total that they grossed across kind of all the movies that they acted in, at least in this data set. This data set doesn't have like every single movie, but it has just like some top movies. And then the number of movies they acted in, what was the average that the movie grossed, and then the number one movie that they had, and like how much did the number one movie gross, essentially, in revenue. And so this isn't like totally up to date. There's a few newer Avengers movies that probably should be on here, but this is a little bit older. But you can just kind of see these are like kind of the top grossing actors in terms of like the movies they've been in, not necessarily by like individual compensation. And so one thing we can do is maybe take a look at the number of movies for each actor, and also look at like what's the total gross and see if there's any interesting patterns there. I mean, you would expect that like if you've acted in more movies, you've probably grossed more in general, right? But let's just take a look at if that's actually true. So we can do this pretty easily. We just take our actors table and then do scatter, and then we're just going to pass in a couple things. So we're going to do number of movies on the bottom, and then total gross is going to be kind of on the vertical, the y-axis. And so we can take a look at this here. So it's kind of interesting. So you can see kind of what we were what I just said, which is like, if you acted in more movies, typically you're going to be grossing more. Not always, it's not like a really clear trend, but it's like clearly seems to be sort of going up. You do have like one person over here, who didn't really act in a lot of movies, but still managed to gross like a really good amount, which is kind of impressive. But in general, we can kind of see this. And another thing we can also do is, instead of looking at just the total gross, which is like, you know, in general, if you act in more movies, you should be making more total. Let's look at the average gross. Maybe that's a more of an indicator of like the quality of your acting or something, right? So like, are you grossing more on average, regardless of like how many that you do? And so maybe instead of total gross, we can look at average. So we can do average per movie and see what that looks like. And so this is kind of interesting. So basically, like if you act in more movies, it seems like they seem to not do as well on average. Or maybe it's just like self-selection, like there's just some actors who only do like a few movies and always like knock it out of the park. But there is one person here, which is like pretty crazy. They've acted in such few movies, less than 10, but like the average gross per movie is like super high, like way higher than anybody else. So we actually try to figure out who that is. So we can do actors.where, and we can try to find we just want the person whose average per movie is above some number. So it can be like any number in this range. Like we can just do 400 just to be safe. And so we see that it's Anthony Daniels. The #1 grossing movie for this person was Star Wars: The Force Awakens. Might be updated, might be a little bit out of date, but any ideas on who this is? Yeah. Yeah, C3PO. So let's go back to the slides here. If you're not familiar, this is Anthony Daniels. So he's the actor for C3PO. So, you know, mainly just in the Star Wars movies, didn't really do too much else, but like knocked it out of the park every time. So really good at choosing what movies he does. So it's kind of funny. So any questions about that example or any of the code that we did there? Cool. All right. Sweet. So just to kind of recap, basically we have these like two options for when we're trying to plot two numerical attributes against each other. And so the first option is just table.plot. Again, you can pass in two attribute names, or you could just pass in one attribute name and it'll just try to plot everything else against it. And then we have table.scatter. So just two options there. And then when should you use a line plot? So you should typically use it when your x-axis has an order that's meaningful. You know, so like if you're looking at something over time, right? There's like an ordering that you care about there. And then the sequential differences in the y values are also meaningful. You know, so if you wanted to see like the number of movies over time or something like that, you actually care about what the differences are there. And the most common one is going to be basically like x-axis is time or distance. That's usually when we're going to be using line plots. It's like pretty rare to use a line plot when you don't have time or distance on the bottom. And this third bullet point, I think, is the one that's like really easy to remember and like the most important one, which is like there should only be one y value for each x value. So what that means is like if you trace your eye from left to right, you should just see one value at the top. You shouldn't be seeing multiple values. If you ever see multiple values, then like a line plot doesn't make sense. And then pretty much, if it doesn't make sense, use a scatter plot. So in general, you can basically, the good thing is you can do every single time you have two numerical attributes, you can do a scatter plot. Like you can always do a scatter plot. There's just gonna be some times where a line plot is better than a scatter plot. That's like another way to think about it. Cool. So any other questions about that? Sweet. All right, let's do categorical attributes at the end here. So we'll do categorical and numerical actually today. So a little bit of both. So in this case, we're going to be looking at movies and which ones are like the highest grossing movies. So rather than looking at actors, we'll focus on movies. And so we're going to have a couple additional attributes here. So we have like the studio, such as like MGM or Fox, like the gross, like revenue of the movie, gross adjusted for inflation, and then the year that the movie came out. And so, you know, studio here in this case is a good example of a categorical attribute. You know, title is as well, but in this data set, title isn't that interesting of a category because it's like this, there's only one of each category essentially. But with studio, you can see like repetitions. So multiple people could be from Fox. Well, I mean, multiple movies could be from Fox, multiple could be from Universal, and so on. And so we'll just take a look at this data set now and do some visualizations with categorical attributes. So we're going to read in our table here. So this is a slightly different table. Has a name Top Movies 2017. So a little bit out of date. And then we can just take a look at this really quickly. So it looks basically the same as what we saw. And so you have all the kind of like top movies for each year. And so this has already been sorted actually. Before we read it in, someone who created the CSV file already sorted this by the gross adjusted revenue. So you can see like starts really high and then goes down. And so again, this isn't something that we did in Python. It was just done externally when the CSV was prepared. It happened to be in that order already. And so what we're going to do is we're just going to take the top 10 highest grossing movies adjusted for inflation. So basically what that means is in this table, we're just going to take the top 10 rows. So it's already sorted for us. And so let's call this top 10 adjusted. And then the way we'll do this is we'll do top movies dot take. So we mentioned this method on Monday's lecture really briefly. Take is what lets you take certain rows, whereas where lets you take certain rows based on a criteria. And so take, we're going to do, let's take the first 10 rows. So np.arange 10 will let us do this. This is going to give us everything from 0 like up to 10, but not including 10. And then we can just take a look at what this gives us. And so here we have the top 10 highest grossing movies adjusted for inflation. And so another thing I want to do really quickly is just adjust again these values so that they're a little bit easier to read, because they have like a lot of additional zeros, and like maybe we don't necessarily need to see all those zeros or the additional numbers and digits there. So one thing I'm going to do is take that column of the gross adjusted earnings and just divide it by 1,000. So the numbers are like a little bit easier to read. And this will just be like important and nice to have for our visualization. So we're going to take the top 10 adjusted, take the gross adjusted column, and just divide that by, let's do like 100,000. Actually, let's do 1 million. And then we can round this to 3 decimal places and assign this to millions. And then I'm just going to add a new column to top 10 adjusted, which will have the adjusted gross revenue, but divided by 1 million. So we're going to do top 10 adjusted with column. Let's just call this millions, because basically it's going to be represented as like the number of millions. And then we can just take a look at what this table has now. So this is all essentially we did. We just added a new column at the end here with millions. And it's just the same value here, but adjusted by that. So basically Gone with the Wind adjusted for inflation made like $1.8 billion, I guess, apparently, which is kind of crazy. And so let's try to take a look at the millions column as a function of time. So let's see like how that's changed maybe over time, like if the gross has like changed if you adjust for inflation. So we can do this, we can just do top 10 adjusted, and then plot year, millions, and we can take a look at this. So this doesn't look too great because there's almost seems like there's potentially multiple values here, right? Like in this one, for example, so there's like maybe 2 movies here. This one for sure, there's 2 things going on here. So like a line plot probably isn't the best choice here. And so maybe another thing we can do is we could do a scatter plot, but we could also just take a look at a bar plot, like a bar chart. And so instead of year, we could take a look at title. And so if we do this, we can actually plot a category against the revenue that's received. And so here we can see basically what we saw on the table, but we can just see it sorted out, and you can see kind of like the actual values for each one. And so this lets you visually represent the table. For the plot above, probably a scatter plot would be the way to go. That's just an example of a line plot not working. But bar H basically lets us do a categorical variable against a numerical variable. So that's the main thing. So there's kind of 2 possible things that we basically covered. It's like numerical against a numerical, or a category against a numerical. And bar H lets us do that. It's bar H doesn't sort this automatically for us. It was already sorted. So that's why it kind of looks like that. So any questions about the bar H? Yeah. Oh yeah, that's a good point. Yeah, so for the other charts that we did, like the plot and the scatter, the first argument was what is on the bottom, whereas for bar H, the first argument's actually on the right here. So it's a little bit subtle here, but basically, typically when you do bar charts, you're kind of used to seeing them going up, right? You're probably used to seeing like bars going up and like maybe the categories or something on the bottom. So that's kind of like the default way of doing a bar chart. And so normally you would have the title on the bottom and then you'd have the values like shooting up. In this case, like the values are just super long. And so you'd have to like rotate that 90 degrees or something to make it fit on the bottom, and it would look kind of messy. And so this is a horizontal bar chart. That's why it's called bar H. So it's almost like a flipped bar chart. So that's kind of why. So a little bit convoluted, but that's kind of the way it is. And so basically it's like the first argument in this case is like the category. And then the second argument is the numerical thing. Yeah. Sorry, I can't hear you too well. Oh, the studio names? So we could do the studio names. I don't know if it's, I think one issue with this is it's gonna probably have repeated values. But we could try with the studio name. I think it might not having repeated values. Although actually this one, there's only 10 movies, so we could see what it does. Yeah, so in this case, it's actually gonna show them repeated. There is a way to group them together, which we're gonna cover, I believe, on Friday, or if not Friday, we'll cover next week. So you won't be able to just do this right away, but there is something that we can do which like groups everything together, and then it'll like, then you'll be able to actually look at just a unique studio name on each kind of part of the y-axis. Yeah, but by default, it's not gonna do anything too clever for you. It's just gonna like basically just show you what's there in the data. Cool. Any other questions? Okay. So yeah, maybe one thing worth doing is trying to generate a chart more like this. So in this case, what's being shown here is it's the top 10 highest grossing movies on here on the title. And then on the bottom, we have the number of, oh man, I can't see it. Oh, the years since release, the number of years since release. So it's like a slightly different way of doing it. And so if you wanted to do this and show the years since release, how do we do that? Well, we'd have to actually create a new column for the years since the release. So since we have some time, I might as well just show you guys how to do this. Basically, what we want to do is convert this column year into years since release. And so the way we would do that is we would make a new column here. And so again, you should just write this out. So first, let's grab the year. So that's going to be top 10 adjusted, top column year. And then what we can do is add this to our table with a new column called age. And the way we can calculate age is we can just take the current year and then subtract the year that it was made. That'll essentially give us the age of the movie. How many years has it been since it was released? And then we could do top 10 adjusted, let's say, and then do a bar chart of title and the years, or so the age, sorry, which is basically how long it's been since it was released. And so then we get something more like this. And so here we can see it's the same top 10 movies that we had in the chart above, but now instead of plotting like how much revenue they generated, we can just look at how long it's been since they were released. And this is maybe a little bit more of an interesting plot because the other one was already ordered by the revenue, so like it wasn't as interesting. But here we can actually see like how old these movies are. So this is like the top 10 movies, like basically, you know, since I think the 1930s or so, and you can see kind of what the age is. And so like you have a couple in the top 10 that are really old. Most of them are like around 40 to 60 years old, and then you have one that's a little bit more recent. And so then you can interpret that pretty easily using the bar plot now. So any questions about that? Yeah. Oh, can you relabel the chart title without relabeling the column? I'm not sure if you can do that actually. It's a good question. I mean, there's definitely a way to do it in Python. I just don't know if the data science module lets you do it in the same way. But that's a good question. Yeah, I can look into that though and get back to you on that. But yeah, in general, the easiest is to probably just relabel the name of the column itself in the table. Any other questions? Okay, cool. Cool. So just a few final things to just cover here in terms of just good visualization habits to remember. So please don't make visualizations like this. So this is a pretty cool graphic, actually. It's showing kind of the median income of like doctors versus other professions from the 1930s to the 1970s. But there's just kind of like a lot going on here. You have these like plots, you have this same exact graphic like again and again and again. And it's just like, when you have stuff like that, you're just showing the same thing again and again. It's not really adding additional information. So, don't like clutter your graph with additional things that aren't needed. Keep it simple. You want to just convey your idea as efficiently as possible. And so instead of that, try to do something more like this. It doesn't look as fancy, but at least it gets the point across. And what's also cool about a line plot versus a bar chart, right? So another thing to think about here is, if we look at, for example, what's the year there, 1970? Yeah, so if you look at, for example, going from 1967 to 1970 versus 1970, 1972, this jump is a little bit smaller than this one. And it's like, you can kind of tell, but then if you go from this one, 1972, 1973, like, is the jump to the right bigger or is the jump to the left bigger? I can't really tell if I use a bar chart. Like, I kind of have to like eyeball it and like figure out what's going on. But if I do it on a plot, it's much easier. I can like easily see that like the slope of this one is higher than the slope of this one. So this one's probably like a bigger jump. And so there's like another advantage there of using a line plot. So it's just a little bit easier to make comparisons of like how things are moving versus using like a bar chart. And so in general, try to use bar charts when you have a good category. If you have two numerical things, you should just try to use line plots in general. And just kind of general good practices. So, minimize decoration, don't add like additional things. Choose your colors pretty carefully. The data science module is going to choose blue and gold most of the time, but you can customize that a little bit. And then really try to preserve the difference in relative values when you have something numerical. And so a line plot lets you do that really nicely. There's a nice book about this. And then the last one I'll leave with you is an actual graphic that was shown on TV. So this was a long time ago, but it was showing like what happens if the Bush tax cuts expire. And so it's showing like what the tax rate is now and what's going to become. And so it says like 35% here, and this is like, I don't know, 39% or something like that. And so there's another case of like, look at the y-axis. If you actually made the y-axis, it would look more like this. And if it started at 0, so this one's starting at 34 and going to 40, which is just like, why are they doing that? So keep that in mind. Look at the y-axis and make sure it starts at 0. Thanks.